Hi everyone, this is SK Singh from DPS Mathura Refinery. Dear children, today we will proceed to the next chapter, that is Inverse Trigonometric Functions, chapter 2. This is a very important chapter, not only with the exam CBSE board point of view, but exam competitive point of view also. Before proceeding to this chapter, let us once again go through the concept which have already gone through in class 11 or in recent past. Dear children, just look at the concept number 1, which we are going to use in this chapter. In class 11 we have already understood that if mod x equal to a, right, this implies that x equal to plus minus a. This is very important result. Point number 2, if mod x is less than equal to a, implies that x equal belongs to minus a to a, right? Suppose if I say mod x less than equal to 3, this implies that x belongs to minus 3 to 3. Point number 3, if I say mod x greater equal to a, implies that x belongs to minus infinity to minus a. Take this point because minus a will be included, union a to infinity. So these are the three concepts, and a few more things can also be understood in class. Let us consider a function f a to b y equal to fx is a function. See, so if we represent it graphically, so it will be taken x-axis and y-axis. So the set of all possible values of x, the set of all possible values of x is known as domain A, and the set of all possible values of y of the function known as range B. Suppose this is a function y equal to fx. Say, here we have in the previous chapter gone through the concept, the function a to b y equal to fx is invertible only when the function is 1 1 and the function is onto. Let us see, suppose if we draw a line parallel to x-axis in this graph, suppose this line is drawn parallel to x-axis, then you can see at a particular value of y, suppose it is y naught, we are getting two values of x. So you can see the first value is x1 and the second value is x2. So you can see the two values x1 x2 will get the same value of y. It means the two values x1 x2 belongs to the domain which are having the same image. So the function is no longer is 1 1. fx1 and fx2 both are equal to fy. So the function is not 1 1, so therefore this function can never be invertible. So if we suppose a graph of a plot, if plot of a graph is in front of you and you draw a line parallel to x-axis in the domain, and if it is intersecting the graph more than one point, it means function is many one, and this cannot be invertible function, right? And if suppose we draw a line parallel to y-axis and it intersect more than one point, then it will not be a function. So in order to be a function, it is necessary that if a line drawn parallel to y-axis intersects the curve only at one point. Suppose we are making a line parallel to y-axis this, so it is intersecting this graph only at one point. If it is plotting the graph another line, it is intersecting one point. If in case suppose on plotting a line parallel to y-axis and it is intersecting at, suppose this is a graph, it is x-axis and this is y-axis, and we are plotting a line parallel to y-axis and it is intersecting 2 points, it means one value of x we are getting two values of y. It means one point in domain have two images in codomain, which is not possible in case of function. These points must be taken care of. So before proceeding to the chapter, let us look at this is a function, this is a graph of y equal to sine x. Look at this graph. Just for the sake of convenience, if we are plotting a line parallel to x-axis, you can see this line is intersecting at many points. So here one value of y, you are getting more than one value of x. So for these values of x, we'll get the one value of y. It means different values in domain have the same image. So this function is not 1, 1. But if we are plotting a line parallel to y-axis, it is intersecting a one point at every point, therefore it is a function. If on plotting a line parallel to y-axis, it is intersecting one point, then it is a function. If it intersects more than one point, it will not be a function. So in this case, we have come to the conclusion that y equal to sine x is a function, because on drawing a line parallel to y-axis intersecting at one point, and since on drawing a line parallel to x-axis it is intersecting more than one point, therefore this function is not 1, 1, and therefore this function is not invertible function. So y equal to sine x is not an invertible function. This point must be taken care of. But if you just imagine, we are putting two restrictions on this function. Suppose the value of x, instead of taking the whole real number, we are restricting it between the two values. One value is, that is, minus pi by 2 and plus pi by 2. Say if we are only taking this branch from minus pi by x value from minus pi by 2 to plus pi by 2, and then we are plotting a line parallel to x-axis, you can see it is intersecting the curve at only one point. If the domain is restricted from minus pi by 2 to plus pi by 2 in y equal to sine x, then it is a 1, 1 function, because any line drawn parallel to x-axis intersects the function at one point. As well as on drawing a line parallel to y-axis, it intersects only at one point on the curve, therefore it is a function. So this function is 1, 1 on 2 only when the domain is restricted from R to minus pi by 2 to plus pi by 2. So here we are suppose restricting the function from f minus pi by 2 to plus pi by 2. You can see here the possible values of y. The upper value of y is plus 1 and the lower value of y is minus 1. So it is going from minus pi by 2 to plus pi by 2 to minus 1 to 1. So y equal to sine x is a function, is 1, 1 and on 2 if the domain is taking from minus pi by 2 to plus pi by 2 and range is taken from minus 1 to plus 1. So this function, say this function is taken from minus pi by 2 to plus pi by 2 to minus 1 to 1, and function is y equal to sine x. Then function is invertible function. So this function is invertible under this domain and range. And when we are going to find out inverse of this function, the range will become domain and domain will become range. So the inverse function will have minus 1 to 1 to minus pi by 2 to plus pi by 2. So it is the inverse function. It is known as sine inverse function. The one point is clear, that in order to make the function y equal to sine x invertible function, we have to restrict the domain from R to minus 1 to 1, and r2 minus pi by 2 to plus pi by 2, and function is directed from minus pi by 2 to plus pi by 2 to minus 1 to 1. So inverse function will be from minus 1 to 1 to minus pi by 2 plus pi by 2. So inverse function minus 1 to 1 is the domain, and minus pi by 2 to plus pi by 2 is the range. So let us consider this function. This is a y equal to sine inverse. We are plotting a curve. You can see this function is y equal to sine inverse function, and this y equal to sine inverse function is taken from, what is the domain? The domain of x is taken from minus 1 to plus 1. So domain of sine inverse x is minus 1 to 1. And what is the range of this function? Range of this function, you can see the value of y, the value of upper value of is plus pi by 2, and it is minus pi by 2. You can see the darkened one. You can see this dark portion is restricted from minus pi by 2 to plus pi by 2. So this inverse sine inverse x is, domain is minus 1 to 1 on x-axis, and on y-axis we have minus pi by 2 to plus pi by 2. So it is the range. So this restricted branch is known as principal branch. So a given trigonometric function can be converted into non-invertible function, can be converted into invertible function while restricting its domain and range. Now look at this function. This is a graph y equal to sine x, and this is a graph y equal to sine x, and this is a graph y equal to sine inverse x. Okay. You can see this y equal to sine inverse graph is the mirror image of y equal to sine x graph across the line y equal to x. You can see y equal to x is the line, it is acting as a mirror, and this y equal to sine x, you can see y equal to sine x का जो ग्राफ यहाँ से ये वाला ग्राफ जो आ रहा है, इसकी its mirror image is forming to the this side. So we can say sine inverse x, the graph of sine inverse x is the mirror image of y equal to sine x about the line y equal to x. This is very important point. So here we have discussed the domain and range of the function. So in short, the domain and range of the function can be redescribed as in this way. This is the first lesson. You must, before proceeding to this chapter, you must keep this table into your mind, without which we cannot find. The possible values of the x is known as domain, and the possible value of y is known as range. And the restricted branch in y equal to sine x or y equal to cos x in trigonometric function, for which the function is invertible. So many branches are possible. Among them, the basic branch which is near to the origin is considered as principal value branch. This is the principal value branch. So you can see the sine inverse x is a function. Its domain is minus 1 to 1 and range is minus pi by 2 to plus pi by 2. And cos, in similarly it can be shown easily, y equal to cos inverse x, its domain is sine inverse x and range is 0 to pi. In the same way, other can also be cosec inverse x is, it is minus 1 to 1 and the are minus 1 to minus 1, and here are minus 1 to 1, and the range is minus pi by 2 to plus pi by 2, minus the middle value, and here the sec inverse x, the domain is same, and range is 0 to pi by 2, and the tan inverse x are minus pi to plus pi by 2 and 0 to pi. So one very important result, can you see how can we keep this table into mind? You simply write down y equal to sin inverse x, cos inverse x, cosec inverse x, sec inverse x, tan inverse x, and cot inverse x. And you can see you alternatively write minus pi to plus pi by 2, 0 to pi, minus pi to plus pi by 2, 0 to pi. You can see that minus pi to plus pi by 2, 0 to pi, 0 to pi, minus pi to plus pi by 2, 0 to pi, minus pi to plus pi by 2, 0 to pi. You can see these alternatively values is changing, but in case of cosec and sec inverse, we have the middle term out of it, that is minus 0 and minus pi by 2. And in domain, you can see the sin inverse cos inverse x minus 1 to 1, this can be written as mod x less than equal to 1. In both the things, the domain minus 1 to 1 is domain is nothing but mod x less than equal to 1. In cosec inverse and cosec inverse x, you can see mod x is nothing but greater equal to 1. Mod x is nothing but mod x is greater equal to 1. It is the domain of cosec inverse x and cos inverse x. In case of tan inverse x and cot inverse x, the domain is R. So in sin inverse x, cos inverse x, domain is mod x less than equal to 1, that is x belongs to minus 1 to 1. And in cosec inverse x and sec inverse x, mod x greater equal to 1, that is x belongs to minus infinity to minus 1, close interval, union 1 to infinity. In case of tan inverse x, cot inverse x, the domain of the function is R. In the same way, the range of this function is sin inverse, cos inverse, cosec inverse, sec inverse, tan inverse, and cot inverse is minus pi by 2 plus pi by 2, 0 to pi alternatively. In the sin and cos, minus pi to plus pi by 2 close interval. In cos, 0 to pi close interval. In cosec and sec, both will be enclosed, but the middle term can be taken out of it. Minus pi to plus pi by 2 in case of cosec, minus 0 because 0 lie in between, and in sec inverse x, 0 to pi and taken minus pi by 2 out of it. In case of tan inverse x, minus pi by 2 plus pi by 2 open interval and 0 to pi open interval. Here you can see in tan and cot, the range is converting from close interval to open interval. In sin inverse, cos inverse, both are at close interval. In cosec and sec, they are in close interval, but the middle term taken out of it. And the first two, sin inverse x, cos inverse x, the domain is mod x less than equal to 1. In cosec inverse x, sec inverse x, mod x greater equal to 1. And in case of tan inverse x, cot inverse x, the domain is R. So dear children, you first today go through these three important concepts, and then we will discuss the questions one by one. Very important. The first of all, today's homework is number 1. You plot the graph of sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x in your copy. So once again, you go through the graph of these inverse function, and this is the graph of sec x and this is the graph of sec inverse x. To plot these graphs in your copy, number 1. Number 2, you just keep these keep this table in your mind. This is absolutely very important table. Without this table, you can't proceed in this chapter. You have to keep in mind this table very clearly in mind. You can see sin inverse and cos inverse x. The domain is mod x less than equal to 1. That is, x belongs to minus 1 to 1 in these two. So here mod x is less than equal to 1. What is the range? Minus pi by 2 plus pi by 2 in case of sin inverse x and 0 to pi in case of cos inverse x. ऐसे in case of cosec inverse sec inverse x, mod x greater equal to 1 is the domain, and again minus pi 2 plus pi 2, 0 to pi close interval, and minus of middle term, that is minus pi 2 plus pi by 2 minus 0 and 0 to pi by 2 minus pi by 2, and tan inverse cot inverse x, domain is R, and again minus pi 2 plus pi by 2 and 0 to pi. These are the range. So keep this point in mind and just go through. Then in next video I will try to reinforce this concept into your mind. This is one of the difficult but very understandable question, logical question. Once you got this concept in your mind, it will never go out of your mind. Okay beta, all the best. God bless you. Keep hustling. Thank you.